问题。So 如果有就大家都 OK 的话，就给我 thumbs up 回应，或者是等等的。好嘞。OK， 今天是星期三，明天我们要去伊朗嘛，对不对？那最后是有几个人？3个学生跟我就4个人而已，是不是 ？OK， 那很开心啊。Yeah， 对，我一直都想去卡布拉，没有时间去，所以 Yeah， 幸好。那我的老婆说我可以买几瓶 whisky，so yeah。OK， 我发现就是对喝酒的文化或者是看法，日本跟台湾差很多。我不说哪一个比较对 ，OK， 就是日本人很喜欢喝酒。Then allow me to go through a how to create, manufacture the soft robots, okay? And honestly speaking, I am not a robot expert like Professor Lin, okay? And I'm not a manufacturer engineering expert, even I'm with manufacturing engineering group. But see, I enjoy learning new things. So I checked a couple of websites, and so I found out in the process of designing and making the soft robot, I think the toughest part is how to design the mold, okay, shape for creating the soft robot. Okay, all right. So most of majority of my time today's presentation in the afternoon, I will use SolidWorks. Okay, here. Okay, the best way is, I wish we could go down to the computer room. Everybody shows up there and use the SolidWorks to play with it. But I have created quite thorough PowerPoint, so hopefully that will be enough for you to play with it. Okay, all right. Okay, so here we go. So soft robot, right? Okay. Oops, there it is. Okay, so here is the most simple, simplest form soft robot. And if you go to here, how come I cannot hyperlink? Okay, it's okay. Okay. All right. Okay. Here we go. Okay. All right. So as you can see, this robot has 3 fingers, right? And it can close it. Okay, of course, you can hit it with hammer. I don't see the point, but you can ride over with a car, but can still close it. Okay, inside it does not have the hard object. Okay, so and I found out most soft robot has similar features. Okay, right, similar structure. And just adding, basically the finger structure is exactly same. If you want to have a more complex soft robot, you can add the finger, connect the finger one after another so that it can bend one way, another way, so on and so forth. That's what I noticed, okay? And this person not only could posted the YouTube video going through the overall process of how to make this soft robot. Also, he has created, or maybe she, yeah, I think it's he. The voice was male. Okay. He also created this instructional web page going through the entire process in a very detailed manner. So you can take a look at it. And he is not using any fancy 3D printer. Okay. But in our case, we get to use the 3D printer. So we will use it. But anyway, so let's talk about it, right? Okay. This is a soft robot. Okay. To want to grab something, at least I think we need the 3 finger, right? more is better, but I think 2 will not work unless the finger is very wide. Okay, so here we go. Let's discuss this one a little bit. Okay, all right. So the mold, okay, mold is the case. Later you can pour the mixture of silicon and epoxy. Okay, then you will create the shape of the robot, and you can pull this one out, so on and so forth. So this is the mold. Okay, of course, again, later in the afternoon, I will talk about how to create this kind of mold using the SolidWorks. Okay, but as you can see, okay, this one, this rectangular block is the air chamber. Okay, this is the block. Here's the solid block. Okay, later if you pour the silicon and epoxy mixture, this space will become empty, right? Right? It will be empty. And in between, there should be a air pathway. So air pathway, in this case, he used the glue gun to create a very rough Y-shaped object here a couple of times. Okay, so basically this structure has a finger. Inside the finger, there will be an air chamber. Okay, 1, 2, 3. In between, these air chambers are connected by air pathway, and the air will be blown into this junction. Okay, that's the idea. Okay, all right. So side view looks like this. Okay, side view, it has a very thick spine. Okay, and here is the very big air chamber, right? And the air chamber is connected with the air pathway. Good. All right. Then underneath, this silicon mixtures are glued onto. In his case, this base layer, he used the flexible paper. Of course, the paper is coated with the mixture too. So paper layer coated with mixture and top layer created by the mold. This gray part is the mixture between the silicon and epoxy glued together. Good? All right. So right now is resting. Right, finger is resting. Okay, and we are going to blow in the air. Okay, and what will happen is the spine, because the pressure accumulates inside, so spine gets pushed up, right? Okay, makes sense? Good, all right. Then eventually, if you blow enough air inside and create enough pressure, okay, what will happen is this entire spine part, this thick spine part, get bent up. Because of that, this lower paper layer, the bottom layer, gets bent. Good. Then this part is this bending motion usually is called flexion. Okay, extension, flexion, extension. Good. It's a very simple design, but clever, I think. All right. Any questions? So this can be the template, starting templates. What I saw was basically using this idea again, making this air chamber smaller and connect the air chamber, small air chamber in a serial manner, so on and so forth. Okay. But as long as you can understand this mechanism here, basically you can create millions of different soft robots. Good. All right. So when it's in the fraction shape, bented shape, and grabbing something, okay, I think this is what's happening, right? Okay, so this fingertip will be subjected to reaction force, right? Because the finger is grabbing the cube, and cube will push back with reaction force. right? And in the fraction shape state, we will have bloated, pressurized chamber. And here's the very tiny air pathway. Good. And green dashed line shows the paper layer. Okay, by the way, the paper layer here is allowed to flex, but paper is not allowed to elongate. On the other hand, the spine part can bend or flex, also elongate. That's the beauty of this mechanism. Okay, so two things together, this finger layer and bottom paper layer, after injecting the air, it will blow up and flex, bend, but paper will not elongate. If the paper is allowed to, if this layer is another rubber or something, then we will have completely different thing will happening. Okay, all right. So that's it basically. Then this spine in this case is made thick, very thick, so that this spine can fight against the compression. Okay, this reaction force will come inside this spine. This spine section will be subjected to the compression and fight back. Any question? Good. All right. So that's the basic shape of the our soft robot. Okay. Again, everything else is the combination of this. All right. And okay, what he did was he prepared the base paper or cardboard. Okay, cardboard here and a couple of strips, bigger cardboard strips. They are used for the wall. Okay, because he is creating the Y shape. Okay, Y shape each has the 1, 2 wall, 1, 2 wall. So he prepared 6 strips. Okay, and these strips are used, glued together, made into a thick block, so that we can create the block for air chamber. Good. All right. So first step is, but after preparing these cardboard paper strips, first thing he is doing is the gluing the strips, this cardboard strips, couple of them, make it thicker, then surface, wrap it with tapes, so that the ones when this block is submerged under the mixture, it will not get wet, right? So here we go. This is the block of the air chamber. Okay. All right. Then what he did was roughly sketch the Y shape, glue these blocks onto each finger, center of the finger. Okay. At the cardboard walls. Okay. All of them are glued with the grooves. Okay. All right. Again, we will not do this. Okay. We will do this process by making the SolidWorks mold and use the 3D printer. All right. Okay. Actually, we will not even do this, right? Because we're not going to make a gripper robot. Okay. So highly possible we will just create one finger. Okay. All right. As you can see, he used lots of grooves. Okay, so that when the mixture is poured into this chain, this bath, nothing will leak out. Okay. All right. Then once this bath is made, he connected these blocks, air chamber blocks, with glue guns. Okay. And by hoping this Y-shaped pathway will become the solid air pathway. Good. And the mixture, I don't know whether we are going to use this or not. It's quite popular mixture called the EcoFlex. And when I talked to Professor Lee, he's mentioned his laboratory also used this. So maybe we will use this one. But anyway, this EcoFlex has 2 parts. One is the silicon and one is the epoxy. Okay. Usually recommendation is 1-to-1 ratio mixture. Okay. I haven't checked the result of other ratio. Okay, I have a feeling if we change this ratio to like a 1 to 1.2 to 0.8, it may be harder, or other way around, we can make it more viscous, stickier. Okay, so next week we can try. All right. Okay, so mix it. Then you have to pour. Again, I myself have never done this, but he was mentioning we have to mix it thoroughly, slowly. Then mixture is ready, pour into this bath. Okay. Then if we don't have any, do we have curing heating device? Do we have? Oh, heat. Okay. Then okay, great. So we have the curing chamber. So we just need to put in the chamber like 10-15 minutes to cure it, right? Good. But if you do this at home, he was saying we have to cure it using 4 hours at the room temperature. Good, but we don't need to since we are using the curing device. So 10 or 15 minutes or so, right? And this part is the top layer with the air chamber inside, okay? But in this case, we need to prepare the bottom paper layer. So for preparation for the bottom paper layer, he first created roughly, okay, the very thin wall, Y-shaped wall using the glue guns, okay? Pour the very thin layer of the mixture. Then he put the Y-shaped paper. Paper will act as the bottom layer. It is flexible, it can flex, but it will not elongate. That's the key part, key idea, okay? Then once that's done, on the top of this paper, again, pour the mixture uniformly and create a very thin uniform layer. Then bottom layer is ready. Okay, then after that, glue the top part, finger part, and bottom layer together, then it's ready to go. All right. And to connect the air pipe tube, he just poked with the needle, okay, so that he was able to later connect the tube to supply the air. Good. Then final part is, as you can see, his design is very simple. The air supplying device is simply the plastic bottle, okay, that we can find after we can reuse it from drinking Coca-Cola or something. Then connect the tube, and at the end of the tube is sticking into this hole here. Okay, by doing this way, you can supply air, suck the air in. It's a very clever, simple design. Even this can be done even at the elementary school, I think. Good. All right. And not only that, he also wrapped this each finger using the ribbon, okay? Non-stretching ribbon. Right. Do you have any idea why he is doing this? Wrapping each finger with ribbon. That cannot be extended. How do you think? Why is he wrapping this finger with ribbon? Sort of trying to constrain it. Any idea? My guess is he wanted to prevent this finger to, after you pressurize the finger will try to expand to sideway and top way. By doing this way, he wanted to constrain the tube in the sideway. Okay, so that only the pressure will push the top spine, and because of these wrapped around this way, spine can bend, okay, along this axial direction. I think that is his idea. Okay, all right. So that's it. Good. So that's the end. Then he was able to create very simple. Oh, and one more thing. Once the finger is done, he also again created one more surface layer, okay, using the silicon mixture. Then finally gluing this finger onto this surface gripping surface layer, so that when the robot is going to flex, okay, it can grab something with lots of friction, okay. This additional layer should be able to create the extra friction when it's going to grab the object like this. That's my guess. Okay. All right. So basically, this is something like this we are going to create again. Okay. All right. Another one is, again, here we go. Oh, okay, thank you. Okay. All right. So another one is the similar idea. Okay. All right, similar idea, but the structure of the finger is a little bit different. Okay, and in this case, I think because 3D printer cannot create the big, he has created 4-finger robot. Okay, and I think he had the difficulty creating the 4-finger robot mold using the one 3D printer. So that's why instead he created the parts of the mold, connected all of them together, okay, like this. Okay, connected all of them together. Okay, then connect all of them as one 4-finger mold and poured in. That's what he did. All right. Okay, but basic idea is similar. Okay, so let's talk about this robot now. Right. Okay, and looks different, right? Okay, clearly this is the flex posture. Okay, but unlike the previous example, you can see one air chamber cell here, another chamber cell, another chamber cell. All of them are blowing up. And unlike the previous example, we cannot see the thick spine. Good? Okay, so that's the differences. Okay, instead of having the thick spine, he created many air chamber and pressurized each chamber, and each chamber will open up, okay, into a sector shape or trapezoidal shape. Okay, then if after each of them turn into a trapezoid after trapezoid, then finger will be naturally, it will start flex. That's the idea. Good. Okay. Again, it's clever invention. Okay. So side view, I think should look like this. Okay. It has the air pathway. Okay. And in each air pathway is connected to smaller chamber. Okay. This pathway should be thinner, sorry. Okay. And this air chamber is bigger. All right. But it's not separated. If they are separated, then air cannot go in. But basically, this is the idea. Okay. Right. Another clever invention, right? Okay. So what will happen is if you blow in, okay, because it's sitting on the surface, so the top portion get pushed up, right? Okay. And each chamber get pushed wider slightly. Okay. Then eventually it will flex. Then this chamber will become like a air balloon and get pushed out. And I was too lazy to draw trapezoidal shape, but this shape shouldn't stay rectangle. It's more like a sector shape or trapezoidal shape, okay, or triangular shape. So triangular shape with pressurized membrane on the surface, triangle shape with pressurized membrane on the surface. So triangle after another, one after another, it will become flex the finger. Good? Okay. And this, but basic concept is same as the previous one, right? Okay. All right. Okay, so here's the top view, okay, of the mold, all right? Basically, mold has the bus top shape. Okay, here's the wall of the mold. Okay, if you have a big enough 3D printer, we can make it as one piece, okay? Later, I will talk about, this afternoon, I'll talk about how to make this one in one piece using SolidWorks, okay? All right, and as you can see, there is an air chamber. Okay, and in his case, there's a hole here, then air tube is connected to this part, okay? All right, and this is solid, all right? And this, each air chamber cell, kind of surprising to me, all of them are kind of thin, okay? Plate sitting here. So this is solid, connected to this solid pipe, solid connected to solid pipe. Then you pour in the mixture again, okay? Then you take out after cured. Then you can get, it's not so clear, but you can see the rough pathway of the air chamber, rough shape of the, air pathway and the rough shape of the air chamber here. Good? All right. Okay, and this alone cannot do anything. Okay, because this part is completely open, so we cannot draw in anything. So just like a previous example, he also created the bottom layer, flexible bottom layer. Instead of using the paper, he used the cloth. Okay, on surface of the cloth, he poured the mixture in a uniform manner. Okay. Sorry, let me go back. So in his case, unlike the grip one, this bottom layer, he didn't use the paper, okay? He used the cloth, all right? Cloth layer, good. And the idea is it's flexible, but cannot elongate, okay? All right. Okay. Then once it's ready, he grew this 4-finger robot onto this bottom layer. Okay, then the last step is simply cut out the unwanted part. Okay, then that's the robot. Okay, the third type is interesting. I think this is the one Professor Lin is thinking about. Okay, all right, so let's take a look at this YouTube. All right. Allow me to, oh, it's muted. Good. Okay. Oops, daisies. It is going. Oh, yeah, here we go. And here we go. So one of the robot looks like this. Good. Okay. But as you can see, all of them are chambered too, right? Okay. Okay. As you can see, this is enclosed chamber inside the air chamber here, air chamber here, air chamber here, air chamber here. Every time you blow in the air, okay, there is an air duct connected to here, but this will open up slightly, turn into a triangular shape, triangular shape, triangular shape. Then eventually it will push everything finger down. That's the idea, okay? All right, and also, video was talking about the wow, it's translating into Mandarin. Here we go. Okay, here's the human-shaped robot. Okay, or you can think this as a 5-finger robot. Okay, 1 finger, 2 finger, 3 finger, 4 finger, and center part is the fifth finger or body part, right? And all of them, if you pay attention enough, the structure is exactly same as the second gripper. Okay, the finger used in the second grip. You can see the air chamber here. Good, all right? So that's what I said. If you know one way to create the finger by combining different finger shape together, you can create a completely different robot like this, right? Okay, this robot is trying to crawl under this bar here, okay, after it's gone. So what you can see is also, okay, oh, here we go. Similar idea, very similar idea. Okay. And of course, to control this human-shaped robot with 4 legs and 1 body, clearly we need the 5 tubes, right? Because this is 1 finger, this is 1 finger. You can build this as another finger, finger, finger. So we have 5-finger robot connected to each other. So you can see we have 5 tubes here. Each of them will control the shape of each fingers. Good, all right? That's it, basically. Okay, so here we go. All right, okay. So I think what's happening in this case is, okay, what's happening here is at the resting condition, okay, and since after blowing up, this will turn into a sector shape, triangular shape, or a trapezoid shape, whatever you name it, okay, then that once that happens, it will push the next cell. Next cell will do the same thing to the next cell, so it will automatically bend, okay. So that's why in this case, this model didn't show the paper layer, bottom layer, or closed layer, okay? But adding the paper or closed layer at the bottom, I don't think it will hurt, okay? So anyway, all right. So you blow the air in, okay? Then it will go inside. Sorry, I grabbed the previous slide. Basically, each cells are here, okay, and each cell get pushed out because of the internal pressure. Then because of that, each cell will turn into sector shape, sector shape, sector shape. Then this finger will start rotate. Good, same idea, but this one is more sophisticated, meaning it's harder to make. Good, but when I saw Professor Lin's slide, I don't know whether Professor Lin shared with you, he was using this kind of model, okay? All right. So for this human robot, I think what is happening here is, first, we want to push this front 2 legs slice through under this bar, so it's flat, and the body is flexed, and the back and leg is also flexed. Then this will act as the hinge or friction point, extend, this will slide forward, right? Good. Okay. Oh, first, most of them are bended. Oh, no, pushed forward. Then front leg is pressurized. The pressure here is released. That means this is frictionless. Then this will flex, and this will act as the hinge. Entire body and back end of leg get pulled forward. Okay. Then after that, release the pressure here, release the pressure here, increase the pressure here. Then this will become the hinge point and push entire things forward. Good. All right. So that's the idea. Okay. Again, the big picture here is each of them are different, similar finger robot. By connecting multiple finger robot in a serial manner or parallel manner, you can create all sorts of different kind of robots. Good. All right. And this is what at least Professor Lin shared with me. Can we see the snake moving? Yeah, snake is moving. Huh? Good. And the motion of the snake basically has a scale, okay, like fish. Okay, the scale move forward, and each scale slide forward and act as a friction and pull the back end. Okay, so I think this is a true robot created by Professor Lin's laboratory, I think. Did you guys make this? Okay, so yeah. So as you can see, this chamber part is very much like the third grip, right? Each part has the air chamber, broad area in. Okay, then you will try to flex it. Then front part will act as a hinge or friction point. Then back end will slide, so on and so forth, right? Then let it go, it will become flat. Okay, all right. Right, and to create this, later I will talk about it. Or maybe one of we can talk about it. Okay, this is the robot shape. Okay, to create this, okay, inside is the air chamber, air pathway. Okay, to create this, we need to create the mold. Okay, outer casing like this. Okay, and oh, by the way, this one should have, just like many other robot, it should have two layers. So top layer is the air chamber, air pathway. Bottom layer is the, scale. What should I say? Scale finger robot. Each finger is acting like a scale of the snake. Okay, so it should have a two layer, scale layer and the air chamber layer. So scale layer, this bottom is you can create using one mold, create pour the mixture in, pour this out, then you can get this one. Top portion, this picture is showing the three layer. I think we can do it with two layer too. But anyway, so create the mold first, and that's why, in my view, creating this robot, designing is hard, but I think the most challenging part is how to design this mold properly so that you can pour it in, take it out, glue together, you can have a robot. Okay? All right, so this afternoon we will talk about it. Okay? All right, and here's the the procedure for making the robot. Okay? Mix silicon and epoxy together, pour it in, and thanks God, we don't need to leave it outside 4 hours. Put into a curing device, then take out them. First is pressurizing, and the second one is heating, I think. Then we have a complete, so in his model, he has created 3 layers. Okay, then glue together, it's ready to go. Glue together and pump the pressure in, this will start moving. Correct? Okay. All right. And this part is completely out of my league. Okay. And this is the video too. Yeah, this is the complete video. Great. Something like this. Okay, can be done. All right. And I think we are going to create our final goal is we are tasked to create the robot to go through this tube, which has the 18 millimeter diameter. Okay. And this is a direct copy of the Professor Lin's PowerPoint. I think in his laboratory, he created different types of similar robot with different scale shapes, okay, patterns, okay, all right. But we don't need to constrain ourselves to this, okay, all right. Oops, this is. Then he is also suggesting we don't need to have only one layer. We can have combination of 2 robots, okay, connected by the shaft. Then we can thread through this tube, or we can even have 4 robots connected by the shaft, and each of them will try to slide through the wall. Okay, I bet this is more efficient. Okay, slide through the wall. Okay, and our goal is we are tasked to design something like this so that your robot can crawl through the tube, and tube is going to have straight part and curved part, I think. That's the end goal. Good? Any questions? All right, that's about it. Then after that, afternoon, I'll talk about how to create these molds, grip 1, grip 2, grip 3. Okay, and I have a feeling many of you know how to use the SolidWorks, right? Okay, but it's nice to review, so I will use this, okay? And the best way is, I wish all of us has the access to SolidWorks here or other side of the online, then we can do this step by step. But following this PowerPoint, you should be able to do the same thing. All right, so this afternoon we'll be back here, and I will use this my laptop with SolidWorks to show you how to do these things. Good? Okay, thanks for coming. See you in a bit.